So this is our second video illustrating how to work with negated premises. And this is kind of a weird argument. It's very short. The conclusion is negation Q, and we just have the one premise, negation of if P then Q. So we're going to end up trying to use our same strategy. We're going to try to, we have a negated premise. We think, what do we do when we have a negated premise? We get the unnegation for a contradiction. For ID, the unnegation is if P then Q. So we're going to try to show if P then Q. That's going to be our goal, and then apply ID to those two lines. So how do we start every derivation after our show line? We make an assumption, and we can, if we make a conditional assumption, but we can't, so we make an indirect assumption. And now we can bring in our premise. Well, look, we're stuck. The derivation is stuck. There's no useful things we can do with our inference rules. So we want to do this strategy I was just explaining. We want to try to get the unnegation of 3. Okay, so the unnegation of 3 is P arrow Q. It's a conditional. How do you get conditionals? You show them. So what we want to do is we want to copy this, and we're going to say, we can click on here and say show, and we're going to copy in the conditional. Okay, and we're going to complete, once we complete that subderivation, we'll say 3 for ID. So our goal at this point is just to complete this subderivation. This is where things get really weird. All we need to do is bring down 2. We can repeat 2, and then we can say 5 CD. Right? Because that's all we need for CD. There's not actually even a rule that says we have to make an indirect any assumption. We could say assume CD if we wanted to, and that's fine. But we don't need it. That's fine too. The CD rule says when you have the consequent of a conditional, you can apply CD. It doesn't say where did the consequent come from. It doesn't care. That's kind of weird. That's a way in which our arrow symbol, what we have called the material conditional, is different from if-then in English. Suppose we argued as follows in English. We said the Lakers will win tomorrow. And then we said, okay, well, therefore, let's suppose we somehow knew that. So we said, therefore, if the Lakers score fewer points tomorrow, they will win tomorrow. Well, that's definitely false. So if we, let's say we suppose that, what can we reason to this conditional? If the Lakers score fewer points tomorrow, they will win tomorrow? Think, no, you can't reason in that way. So we think in English, you cannot in general go from the consequent of the conditional to the whole conditional. And yet that's what we've done effectively in our derivation here. We went from Q to if P then Q, right? We just said show if P then Q, copied down R and applied CD, and that's a perfectly fine maneuver. And even if we add the assumption, it doesn't. It's still fine, but the assumption is irrelevant. We've still got Q from someplace besides P. So they think, well, this is a bad argument in English. Well, so this should be a bad argument from 2 to 4 in the logical language, but that's not true. Why is that? Because this arrow does not mean exactly what if means. So if P then Q does not say that what if the Lakers score fewer points tomorrow, they will win tomorrow says. And so while this argument in English is bad, this argument in the logical language is just fine, because the arrow and if in English are not perfect synonyms. Okay? They don't mean exactly the same thing. And this argument in the logical language is just fine. Okay, so given that little digression on the conditional, we're now in a position to complete this argument. Why is that? Well, because 3 and 4 are a contradiction, right? 4 is a conditional, 3 is the negation of that conditional, so 3 and 4 are a sentence and its negation, 3 and 4 are a contradiction, and so we can apply ID. Check it. Good. If you have as a premise the negation of a conditional, then you're going to want to go ahead and show the conditional, and once you've shown the conditional, you can then apply ID. And you may get the conditional in one way, you may get it in another way, but that's how you want to proceed. Okay, so in the next video, we'll look at one last example of working with negated premises.